Okay, so this is on rhombi, and if it's one, it's rhombus. If it's plural, it's rhombi. It's Rhombi, and this section's on rhombi and squares, both. Okay. First, the author defines a rhombus. It has all the properties of a parallelogram with all four sides congruent. Okay, a rhombus has all the properties of a parallelogram with all four sides congruent. Okay, and then the author goes through several theorems. The first one is Theorem 6.15. And it says the diagonals of a rhombus are perpendicular. Okay, so you could probably add to this picture the diagonals of the rhombus. These would all be perpendicular. Okay. So Theorem 6.15 says the diagonals of a rhombus are perpendicular. And you can use the symbol for perpendicular. Okay, then Theorem 6.16. Each diagonal of a rhombus bisects a pair of opposite angles. So, example, this diagonal bisects this angle. So this angle is congruent to this angle. It also bisects this angle, a pair of opposite angles. So this angle is congruent to this angle. Same for the other side, yeah. Except mark those like this angle is not necessarily the same as this one. Okay? But it bisects. This diagonal bisects this whole angle. So this one is congruent to this one. And this one would be congruent to this one. Now, you might ask on that one, are the lengths of the diagonals the same? They don't have to be. Okay? So draw a sketch. So Theorem 6.16 says each diagonal of a rhombus bisects a pair of opposite angles. So, number one, we've got a rhombus. Okay? It has all the properties of the parallelogram. So, the one thing I have not marked on here is this one is parallel to this one. This one is parallel to this one. Okay? All four of these are congruent. All four legs of the rhombus are congruent. The diagonals are perpendicular. The diagonals bisect the angles. Okay, but does it say that this diagonal is the same length as this one? No. Okay. So draw a sketch. And the lengths of the diagonals don't necessarily have to be the same. Okay. Okay, the next theorem is Theorem 6.17, and it says if the diagonals of a parallelogram are perpendicular, so if you look at the diagonals, that would be this one and this one. If they are perpendicular, then that parallelogram is a rhombus. So if you go back and look and compare this to Theorem 6.15, this is the converse of that. So if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. And that's actually the converse of 6.15. So if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Okay, the next one's Theorem 6.18. Says if one diagonal of a parallelogram bisects a pair of opposite angles, and this is symbol for angles. If one diagonal of a parallelogram bisects a pair of opposite angles, keyword there is bisects, okay? A pair of opposite angles, then the parallelogram is a rhombus. And that's the converse of 6.16. So you can kind of tie those two together. So what it really says is if you look at your picture, if angle 1 and angle 2 are congruent, and, that's a big and statement. Remember the and statements, both parts have to be true. And angle 3 and angle 4 are congruent, okay, then it's a rhombus. Or if angle 5 and angle 6 are congruent and angle 7 and angle 8 are congruent, then the parallelogram is also a rhombus. So it has to be 1 and 2 and 3 and 4. If those are congruent, then it's a rhombus. Or if 5 and 6 and 7 and 8 are congruent, then it's a rhombus. Okay? So if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. Okay, then Theorem 6.19. If one pair of consecutive sides of a parallelogram are congruent, then it's a rhombus. So if you look at this picture, okay, it only has to be one pair. It has to be consecutive, okay? Not opposite. It has to be consecutive, so touching each other. If one pair of consecutive sides of a parallelogram, now it has to fit all the things for a parallelogram. It has to be a parallelogram. And if those consecutive sides, if one pair is congruent, then it's a rhombus. Okay? If one pair of consecutive sides of a parallelogram are congruent, then it is a rhombus. Okay. Okay, then when you're doing the assignment, and there's no assignment yet for Monday, so for the assignment, when you do the assignment, remember, consecutive angles add up to 180 degrees. That means they are supplementary. Okay. When you're looking at a rhombus. So consecutive angles would be like this angle and this angle. They are consecutive. Okay, this one and this one would add up to 180. This one and this one would add up to 180. This one and this one would add up to 180. Okay? So keep that in mind when you do the assignment. Okay? Okay. Most of the thing on squares you already know. Squares, Theorem 620. If a quadrilateral is both a rectangle and, remember an and statement, both parts. If a quadrilateral's four sides, if it's both a rectangle and a rhombus, and you think about the rhombus is the parallelogram, it's got all four sides congruent, it's got the diagonals perpendicular, then it is a square. If a quadrilateral is both a rectangle and a rhombus, then it is a square. If a quadrilateral is both a rectangle and a rhombus, then it is a square. All the properties of a parallelogram and a rectangle fit a square. Okay. Now I want to look at one example. Draw the picture out at the side. Okay, label this as A, this is B, this is C, and this is D. And E is in the middle, and this is a right angle. Okay? If you're given measure of angle DAB, so DAB, this whole angle down here, this whole thing is twice the measure of angle ADC. Supposed to find the measure, I wrote this wrong. This should say find the measure of angle ACD. Okay. We ended up down here. Hang on, it's in the wrong spot. Okay. So you can use measure of angle DAB, this one, and ADC. Okay. They are supplementary, right? So these two angles, this whole angle and this whole angle, add together to give you 180. Okay? Up here, I said DAB, that angle, was twice ADC. So you should be able to take half of this and half of this. So if you divide this by 2 and divide this by 2, okay? So 1/2 of DAB is ADC. And that's what they're doing. They're substituting in here. Half of DAB is equal to this. So 1 DAB plus a half DAB is 3/2 DAB. Then get rid of the fraction. Multiply by 2/3 on both sides. 2/3 of 180 is 120. Okay. Okay. And angle DAB is congruent to BCD. Okay. They have to be congruent to each other. This angle is congruent to this angle. Okay. And then I substitute it in. Okay, so a half of 120 is 60. Okay, so you may need to look at that for a little bit. May have to go back through that. There's no assignment for Monday. Okay, so you may want to go back through that picture again. Okay, and I do want you to read the section. Look at the examples that they give you in the book. Okay.